Senior Engineer here at Amazon, and welcome to our ongoing series about messaging services. I'm coming to you live from Amazon Vancouver, which I will prove. There you go. There's a view of our harbor, and I'll get out of here and let the camera recover. And you can see why I have to keep this closed, because otherwise I'm going to be a faceless black silhouette. There you go. So, welcome to the series. So today we're going to talk about a service that is not new, the Simple Notification Service, which from here on in we'll call SNS, thereby saving lots and lots of syllables. I've got Sam Dengler online here with me today, who is a solution architect in Atlanta. Now, I know what an SA is, and I bet you lots of you do too, but maybe somebody doesn't. So, Sam, why don't you tell people what it is you actually do here for us?
Hi, Tim. Thanks. So I'm a solutions architect at AWS. I've been here for a little over 2 years now, but prior to that, I was a customer for 3 years. So I've been in the shoes of most of our customers and been working with the services for a while. As an SA, my role is to meet with customers and dive deep on their business use cases in order to understand what their technical challenges are and how we can use AWS services to help delight their end consumers.
So you typically work with them as they're getting into things, as they're looking at the products and then deciding what to do once they're in.
Yeah, I get this question quite a bit. There is no sort of pre-sales role here. Some people are investigating services, some are using it and looking to do new things, some have been using the services for a while. So as SAs, we sort of enter conversations at all points in sort of service usage and knowledge from our customers.
So now I'm going to share sort of a dirty secret. It turns out people like Sam, the SAs, actually know a lot more about the services than people like me who build them. Because they actually get in there and get their hands dirty and build stuff with them. We're just in the back rooms, pouring oil in the engine and so on. So today we're going to talk about SNS. And Sam, if you'd flip to the SNS home screen there. So Simple Notification Service is a classical messaging service of the flavor we call PubSub, publish and subscribe. So the way it works is we have it's organized around topics. And you make an SNS topic, and then you post messages to the topic, and then you can subscribe things to the topic. And the things you can subscribe to the topic include SQS queues, Lambda functions, arbitrary REST endpoints, email via a simple email service, mobile push, you can push it out to people's mobile phones and so on. So the idea is that you write messages into a topic, and then the topic pushes messages to a variety of different things. It's actually a really popular service, and many of the other services at AWS are all wired up to automatically send SNS notifications when something happens. And so a lot of messages really go through there. Now, I don't know if you noticed, but yesterday there was a thing going around Twitter called AWS Drinks, where they talked about bartender drinks for all the different AWS services. And there were only two for SNS, and the first one was the SNS. Every time someone orders a drink, you get a PagerDuty alert. Okay, fair enough. And that's actually pretty realistic, because a lot of people use SNS to send messages when something's gone wrong, and it's really easy to set it up to drive your pager. The second one says, and this is by a fellow named Chris Gervais, and it says, the SNS, bartender acknowledges that you've ordered something drinkable. 2 weeks later, a giraffe arrives. Okay, I mean, yeah, you could do that with SNS if you were in the business of delivering giraffes, but that's maybe a little on the abstract side. Okay, now there's one customer that Sam's been working with lately, and they've got a nice application of SNS that we think shows off some of the finer points and why you, if you have a problem, might want to use it. So, Sam, this would be an outfit called PlayOn. So, you want to tell us about them and what they do?
Yeah. So, the use case we'll be talking about, I wrote a blog on it about last summer. If our viewers are interested in looking at it later, and PlayOn Sports it's a company based out of Atlanta, Georgia. It's a high school sports media company that is partnered with an organization called the National Federation of High School Sports. It's sort of the high school sports version of the NCAA for college sports. And what the company does actually is works with high school students, and they will go to the events and they will operate the cameras, they will do the color commentary, they'll punch up graphics, everything that you see in production broadcasts of sporting events, students do for their own high school sports. and then they're broadcast live on this website, the NFHS network. And what it allows is relatives and high school sports fans to purchase a subscription, a monthly subscription like they would with a Netflix or Amazon Video, and then they can watch the live videos and VOD videos, to help follow their children or their relatives and their interest in the sports. So maybe we could play a video real quick to kind of demonstrate the service to the students, please.
All right, AV folks, you got that video? Cool.
Thanks very much.
They actually host the video, broadcast the video, and let people sign up for it. Excellent. So you ran into them before they were using SNS. Maybe talk about what this picture was like when you got in there and how things were working.
Right. So PlayOn is the sort of streaming platform behind the NFHS network, and it's not unlike Twitch in the fact that there's many events that are streamed on the platform of varying audience sizes compared to, say, like an NBA basketball game, fewer events with larger audiences. So last year, PlayOn did tens of thousands of events. As you can imagine, this type of broadcasting model just isn't possible with traditional channels that you would see with satellite or cable or dish, right? And so it has sort of unique spiky traffic patterns, especially dealing with high school sports, where there's a large number of high schools and sporting events, but actually a small window in which those sporting events occur after school and sometimes on Saturdays. So, for example, in March, PlayOn processed over 20,000 hours of video in a month, but it had a peak of 350 hours of video processed in just 1 hour. That's 2% of the total of the month in just 1 hour, right? So you could also imagine that on a Sunday, when there's no high school sports going on, there's not a lot of streaming and video processing going on as well. So they had a sort of a unique traffic pattern. We really saw large elasticity in the video processing. Originally, the company built the video streaming platform on EC2 using auto-scaling groups for elastic compute. However, the licensing for the video software was not elastic in the same way, so the company was challenged with higher costs for licensing that really fit their model. So in 2014, PlayOn went to reInvent, and that's when Lambda was introduced. And the company really saw a connection between the demos on image processing and what they could do with videos using FFmpeg. And so they came away with that, and they redesigned their architecture to be a serverless architecture and changed the way that they were publishing their videos. So instead of streaming videos using RTMP, they were actually publishing small video segments through CloudFront using an accelerated transfer to an S3 bucket. When the video, 8-second video, hit S3, it would trigger a Lambda function. The Lambda function would then need to have multiple video transcoding jobs operated on that small part of video, right? So when you're streaming video with the players, based on your bandwidth for your network connectivity, needs to play the video at different resolutions. And so there were a number of operations that they would need to perform on the same 8-second video. And so it was a really good model for a fan-out pattern. So at the time, actually, though, when Lambda was announced, it's kind of hard to remember that since it was 2014, but SNS did not initially support Lambda as a target for subscribers. And so initially, PlayOn Sports solved this problem by having a Lambda function do a fan out to the other Lambda functions. And we can take a look at that
on this
code.
Series that we got to show code. So show code. By the way, Sam, we hear there's some echo on the line. Do you have any other live mics in the room there?
No.
Maybe mute your laptop just to be sure. Or, I don't know.
Is that better?
Anyhow, I don't know. Let's keep going.
Okay. So here's the code that initially a representative code for that fan out function, right? So it's a pretty simple function. We have a list of sort of the downstream Lambda functions that need to be executed. And this Lambda function essentially receives the S3 event and just loops through those downstream Lambda functions invoking them asynchronously and just passing on the S3 event payload to each of them. So it's a pretty simple function. However, it had to be called for every execution in an S3 event.
Right. I see you've got invocation type equals event. So that means it's not going to wait. It's just going to fire and forget.
That's right. And this is just representative of their true code. They actually did parallel asynchronous event invocation to reduce the latency of the Lambda function. However, you can imagine with the number of, having over 9 million 8-second segments within a month, even having one Lambda function executed for each of these can add up over time, right?
Got it.
So once SNS, though, supported Lambda functions as a target, Plan was able to sort of refactor their architecture to take advantage of that service change. So instead of the S3 event triggering a Lambda function for the fanout, we were actually able to use SNS in order to handle that event and fan out to the other Lambda functions. So let's take a look at how that changed the code. So in fact, it eliminated the Lambda function that we just looked at to do the fanout. And let's take a look at how the downstream function changed because of this. Initially, the Lambda function handling the event was just essentially receiving the same event that the Lambda handler did for the S3 event. However, when S3 will send the event, it wraps the payload, the original payload, in its own sort of schema and wrapper. So just by adding a simple function that could detect both cases, one where the event is coming raw and one where it's wrapped in the SNS, we can handle both paths, execution paths. And that's what this parse event does. We're sort of glossing over some of the gory details on what these functions would actually do, but in fact, they're calling out to binaries that are included in the Lambda function to do FFmpeg processing. And here's another example of where we're actually using media info. And there's a blog actually that covers this and how you can extract metadata from the video segments as well.
I see they're using FFmpeg. I think if FFmpeg didn't exist, the whole video industry would collapse. Everybody seems to use it for everything.
Yes, it's with FFmpeg, it's all about the right combination of options to accomplish anything.
And so their win here was they managed to throw away some code, I guess?
Yes, so there was a couple of wins here. One is they were able to eliminate the fanout Lambda function altogether. And so there's benefits there just in code complexity. Everyone likes to delete code. But also, as I mentioned, we talked about the number of video hours that were processed in March. Well, as I mentioned, every execution caused a Lambda execution. Lambda is a very inexpensive service, but it was still maybe several $100s in order to include that. So there was cost savings as well. It also reduced the latency slightly by not having to call through an additional Lambda function to invoke the downstream functions.
Right. I would think, compared to the video processing and so on, the latency of SNS would just totally vanish from the equation.
That's right. And then the other advantage is that SNS has its own built-in sense for retrying Lambda functions and logging success and failure, which all had to be handled manually within the own Lambda function originally. So there was some offloading of complexity to other AWS services that have that sort of concepts built into it as well.
That's actually a good point that's worth mentioning. So when you wrote something from SNS to a Lambda, or to anything, to SQS, to a REST endpoint, whatever, it's smart. It'll try really hard to deliver. It'll keep retrying. It'll back off gradually, but it will really give the utmost effort to make sure it goes through. I can remember a few months ago when Lambda had a problem. They had a major fleet issue, and they were failing something like 30% or 40% of their calls. And the people who were going through SNS and other things like step functions basically didn't even notice, right? Because it would just retry a few times and it would get through. So, if in fact you're calling Lambda directly, you're probably going to have to do some retrying and thinking about that. The SDK will do some of that for you. But seriously, for Lambdas that you depend on, and in fact message delivery that you depend on, you really need to have some thought given to retry. And one of the best ways to not have to do that thought is to use SNS, because it'll get through there. Now, since Lambda hasn't been standing still while you've been doing this time, since Playon, we added some new features, and in particular filtering. I'm wondering, looking at this, if filtering would have made their life even easier.
Yeah, so one more optimization in this you'll see is that we've eliminated the Lambda function, but still every message, every video segment that comes through to this SNS topic has to be handled by every downstream Lambda function, whether or not it needs to be processed or not. So an example of this is you would be amazed at the video capabilities of these high schools. There's high schools that produce 4K video, and then in other cases you might be in a rural area where you have really low.
My phone takes 4K video.
Exactly. Yep. You look at Twitch and these mobile video broadcasting units, essentially, right? So, but the inefficiency here is that each of the Lambda function would need to inspect the event in order to determine whether it should process it or it can short circuit the execution. So there's still some inefficiencies there. With the subscription filtering that came out with SNS, if we can put metadata on the message along with the payload, then the subscribers themselves can actually express what messages that they're interested in based on string or numeric logic as well as and/or logic to create fairly expressive situations in order to handle just the messages they want to process and decrease the number of sort of wasteful Lambda invocations.
Uh-huh. And I guess, as an SA, one of your jobs is to notice that and call them up and let them know. So they might do that in the future.
Yes, one of our leadership principles is invent, simplify. We're always sort of looking for opportunities to use the latest services and features. And lots of times, the subscription filtering is a fairly new feature, and maybe customers looked at SNS 6 months ago or a year and didn't know that was there. So we are constantly revisiting services to, talk about the newest state of the art and see if there are new use cases that the customer, can offload complexity to the AWS services and really take on that undifferentiated heavy lifting.
Yeah, this is an ongoing pattern we see at AWS. We really need people like Sam out there because we here in the engineering offices will finish building a feature like message filtering, for example, and ship it and then go out and have beers and be happy about it. And somebody's got to make sure that people who need this find out about it. And so we do press releases and so on. But the kind of personal contact that people like Sam offer is a big deal. Now you told me you had another interesting demo of a clever setup with SNS and filtering and some other neat stuff.
Yeah, so we have another new service that came out. It's a little bit year old now. It's part of our AI services, an ML service called Recognition. Recognition has several features. It can do celebrity detection. It can detect inappropriate material for children. The one we're going to look at right now is something called label detection. And so you can give Recognition a video. An image. You can actually do videos now as a reinvent, but in this case, we're going to look at an image, and we feed that image to Recognition, and it will come back with a list of labels. Those are things or entities that it can detect inside the image using, machine learning models that AWS has created.
Machine learning. Now we're in the hot, sexy future all of a sudden.
It really is amazing. I'm constantly just excited by what I can do these days as a builder with just a few lines of code. It's a great time to be alive. And this example we're showing, this is one of the sample images that we have, and you can see that it's detected some labels, skateboard, sports, and a confidence that it thinks about those labels. So in this case, the Recognition is 99.2% confident that there's a skateboard in this picture. So what we can do actually is we can take a look at what this would look like, right? So if we have images coming into S3, we can have a Lambda function that's tied to those events. So when it sees a new image dropped into an S3 bucket, it can send that image to Recognition, come back with a list of confidence values, and add those as message attributes to the message going to SNS. So Tim, I know that from following your blog that you're a big music fan with your song of the day, and so it could be a case where we're watching the same S3 bucket, you and I. Maybe I'm a skateboarding fan, and you can say that you only want to see messages or you want to see messages for images that have musicians in them, whereas I would like to see skateboarding images. The key difference here is in the past, you would actually have to have multiple topics and push that logic into your Lambda function in order to determine one or many topics that you should publish to based on that metadata. Now customers can have one Lambda function with one message, and as long as the message attributes have a full enough context and the expressions that you can build in the subscription filtering are complete, then you can build that into the service yourself and reduce complexity.
Cool. So enough architecture diagrams. Let's see some code.
I'm sorry, I missed that.
No, enough architecture.
Oh yeah, let's look at some code. Right. Okay, cool. Well, let's take a look at what this Lambda function looks like. In the last ones, we were actually looking at Python code. In this case, we're going to look at some new Node 8 code. So Lambda supports Node 8 just as a couple of months ago. Has a really nice feature now around async and await functionalities in the language that make handling the asynchronous processing in Node much easier to sort of grok as a developer. And so we're demonstrating that with an async event handler for Lambda. And what we're doing is we're just splunking through the S3 event that's coming. So we'll get a list of records coming from S3, and we're pulling out for each one the bucket name and the key. The first thing we're doing is constructing the request to recognition. So recognition, if you're using an S3 object, there's a particular schema you can use to put a reference to that object, and then we can send it to recognition in order to detect labels on this image. And again, this is typically where you would see a node, a callback function, and several depths of curly braces. But we can really simplify this now by returning a promise, which the AWS SDK does for you, and just wait on the response from that. And so it reads more like synchronous code, although it's asynchronous. Once we have those labels back, it's actually going to come in it's an array actually of hashes, the small dictionaries of key value pairs for the labels and the confidence values. And so we have just a small function here, recognition labels to message attributes, that's just going to transform one format to the other and replace any spaces in the labels with dashes, because that's what SNS requires for its labels. It doesn't allow spaces in the keys. So once we do that
I get so sick of the endless chains of callbacks whenever I try and, when I write a computer program, read the data, process the data, send the data. Why do I have to have 7 levels of callback nested deep? That's so much nicer.
It really is, for me, when I get into that situation, I constantly wonder, why is it so hard for me to grok and do? And this has been a game changer for me using Node, and I really enjoy actually coding with it now. Once we get back the message attributes in the format we require for SNS, we'll create another request which has the message body. In this case, we're just we're just saying what bucket and key the image was detected, and we're going to send all the message attributes that recognition detected. If you wanted to, you can tell recognition that you only want the top 10 labels. You have some flexibility in that. In this case, we're going to just capture them all and send them. And then we're going to, again, use that await function in order to publish the message with its attributes and then get a response. The other nice aspect of the new functionality in Node 8 is it makes it easier to do try-catch blocks. So I can have all my logic in one try block and catch errors here without having to do that within the callback functions themselves. So let's take a look at so now we have a message that we're going to publish with attributes. How do we express what we showed in this diagram, which is that Tim likes musicians and Sam likes skateboards? Well, what we'll actually do there is we'll use something called a subscription filter, and this filter is per subscriber. So if you're subscribing with your phone and I'm subscribing with my phone, we can have different subscription filter topics and use the same message topic for inputs. So in this case, I've expressed a simple filter, which is I'm looking for message attributes with the label musician, and I'm looking for a numeric value that's greater than 90. Go ahead.
I see the value of the musician there is actually an array. There's square brackets. What's all that about?
That's right. So the subscription filter policy, DSL, the domain-specific language, also supports ands and or logic. So I could actually have multiple key value pairs for expressions, and they would be ORed together. So you could look for musicians that are greater than 90 or equal to 90 in one expression. So let's say we've applied that to your phone number so that you're subscribed to messages coming into a queue. And what we'll do is, I saw your post recently on Portishead, 90s trip hop, which I'm also a fan of. So let's send this image to the S3 bucket and see what happens. So here, for my command line, we just have the AWS S3 command, which is going to copy that musician image into a bucket that I'm monitoring with my Lambda function. And so let's let that happen. So it's a quick copy that's gone to the SNS, the Lambda function.
Well, that was my phone going off. And indeed, there was, Well, you can't see this, but trust me, there's a text there, and it says, oh, it's the moment, the bucket name, and the name of the video. Cool.
Great. Hooray. So anyway, I think this is, I really like this feature a lot. I think it's a very good example of where we can help customers with the undifferentiated heavy lifting, reduce code, take on the management of the expressions, and how we can deliver this message to bring value to and delight their customers. The other example I wanted to show and talk about.
Hold on a sec there. We have a question from Simon Walter out there saying, how much Fanout can SNS actually do? And well, that turns out to be a big number. We've got a well-known professional sports organization that is doing, between 5 and 10 million Fanouts on particular things. A related question is, well, how much volume can SNS do? And we've got customers pumping, having topics that have like 200,000 messages a second, notifications we're supposed to call them, a second, pumped into the topic. Now, fortunately, the people who are sending 200,000 are not the same people who are fanning out 5 to 10 million, because that means everybody in the planet would get one every few seconds, and that probably wouldn't be friendly to the public. So.
Great. Well, if I could, I just wanted to talk about one thing that's coming that I'm excited about related to this topic, and it's the fact that by the end of Q2, and we announced this at the San Francisco Summit, we're actually going to support Lambda functions using SQS as an event source natively. So many customers have written polling solutions in the interim, but this has been one of the number one requests from customers building serverless architectures. And I was speaking with a customer yesterday that represented sort of this use case where they were going to be dropping data files into an S3 bucket of different sizes. And essentially they wanted two different types of queues to handle those, one for large sizes and one for small sizes. What we'll be able to do once Lambda can talk directly to a SQS queue is drop, just like we showed, we can have a S3 event be processed by a Lambda function, which can transform that and expose the size of that object to an SNS, and then have different queues subscribe to those and have sort of fast lanes or slow lanes, small lanes, big lanes, and tie Lambda functions to the processing or ECS Fargate or other consumers of that queue, and not have to run any sort of pollers as part of the process.
Yeah, that's a win. And furthermore, you draw these architectural diagrams, and they have lots of boxes and arrows on them, but it happens pretty fast. I mean, you folks just heard, you saw him copy that to S3, and maybe 10 seconds-ish later, my phone went off. So that actually went through quite a few steps to get there. But it works fine, and as I said, it can scale way up. So that's cool. Was there something else you were going to show us? Oh,
I was just going to do one more mention on sort of that thing you mentioned, Tim, about how we can create an architecture that looks like this, that combines our topics and our Lambda functions and our queues. And one thing that I like to use is the serverless application model. I have my Sam t-shirt on, or Sam the squirrel, that represents that. And here's an example that actually I used to deploy that Lambda function that rang your phone. Takes an SNS topic and an S3 bucket as inputs, and then I could build my Lambda function that has all the proper AWS security restrictions and wire it together all in a infrastructure as code that I can deploy and update as part of a pipeline. I can't hear you.
Is any of this stuff available on GitHub or somewhere where people can see it?
Yes. So the blog that I wrote, there is a GitHub example for this. It's called the AWS Serverless SNS Fanout. And again, this is showing that sort of trade-off with using the Fanout versus the SNS, and includes the Python functions and CloudFormation templates to run this in your own account.
Cool. Okay, folks, I think we are about at the end of our script here, the things we were going to talk about. If there are any more questions people want to ask, now would be a good time to get them in. While you do that, I'm going to say that next week we're going to be talking to somebody totally different. We're moving from Atlanta to the UK, and we will be talking with the BBC, British Broadcasting Corporation, about some of the extremely high-volume messaging applications they're writing, how things are flowing around the UK, And they had so when I talked to them about the problems they were trying to solve, they weren't the problems I thought they were going to be at all. So I had my eyes opened by that application, and so check it out, and it should be fun. Okay, folks, let me just check the question channel one more time, and not seeing any. The other channel, that's fine. Okay, so Sam, thanks for the time.
Thank you, Tim.
Okay, folks, talk to you next week, and we have at least 4 more of these messaging things in the weeks going forward, and I hope you'll come back for some of them. Bye-bye.
Bye.